this video, we're going to take a close look at the Motor Protection Circuit Breaker, or MPCB. These advanced devices are designed to safeguard electric motors from common electrical issues like short circuits, phase loss, and overloads. By protecting against these faults, MPCBs help extend the motor's lifespan and improve overall performance. Let's jump right into the internal components. On screen, you can see the back frame of the MPCB, usually made from durable plastic or polymer materials. Inside this frame, there are 3 arc-extinguishing electrodes made from copper. Above each electrode are 2 arc chambers, which help extinguish electrical arcs. Next, we position the moving contacts for each phase. A spring is placed under each contact to ensure a solid connection with the fixed contacts. Now, if we examine it closely, you can see how the moving contacts can operate. Next, we assemble the middle frame, which holds the other components in place. The magnetic and thermal trip units for each phase are then installed. These units consist of 4 key parts: the magnetic trip unit, the bimetal for overload protection, power terminals, and the main contacts. On the other side of the middle frame, you'll see additional power terminals and main contacts being installed. Next, an actuator is installed to pushes or releases the moving contacts. When it moves up, the contacts close the circuit. When it moves down, the circuit is opened. The control circuit unit operates this component, which we'll get into next. Now it's time to add the control circuit unit, which manages the switching of the circuit. The circuit is closed manually. You can see in the screen how the mechanism works. When the start lever is pressed, the spring compresses, storing energy for a quick circuit break. When a trip command is triggered, whether manually or by the protective units, the circuit will interrupt it immediately. You can see how manual tripping works here. In the next video, we'll cover how the protective units cause tripping, so be sure to check that out using the link above. If you found this video helpful, please support us by liking and subscribing, and don't forget to share your questions and feedback with us. Some MPCB accessories, such as shunt release and undervoltage release, can also trigger the trip mechanism. There's a 3D animation on this channel that goes over these accessories in more detail. Finally, we install the operating levers and the overcurrent setting dial, followed by the front frame. The overcurrent dial allows you to set the current limit. You can now clearly see how the switching mechanism functions. Pressing the start lever allows the movable contacts to establish a proper current path, as illustrated in the image. When you press the stop lever, the stored energy in the spring is released, swiftly separating the movable contacts from the fixed ones. This process ensures that the circuit is interrupted in the shortest time possible, and any arc generated from the motor's current interruption is extinguished within the arc chamber. If you're curious about how to properly size an MPCB, here's a quick guide. MPCB sizing depends on the motor's total load current, voltage, and operating conditions. The MPCB should have a current rating slightly higher than the motor's total load current. Additionally, the trip settings for overload and short circuit protection should be adjusted according to the motor's specifications. Thank you for watching until the end. We hope you'll stay tuned for our upcoming videos. Please share our YouTube channel with your friends. If you found this video helpful, please support us by liking and subscribing, and don't forget to share your questions and feedback with us.